Hello everybody, I am Professor C.S. Borgalli. I will be discussing a few questions on a topic called atoms, molecules and nuclei. Students, I am sure you have studied this topic, which is very simple, and I will be taking a few questions, the typical questions, and whenever it is required, definitely I shall explain some of the points instead of first explaining all the details and then going to the questions. Moving to the question, what is the energy of electron revolving in the third orbit? And it should be in electron volt. Options are 1.51, 3.4, 4.53 and 4. Now here we will spend little time in recalling the expression. You need that expression, and once you know that expression, immediately you can answer this question. So what expression we need to recall? Here the energy of electron in the nth orbit can be written as minus mz square E4 divided by 8 epsilon naught square n square into h square. For hydrogen, we take it as Z, and if you substitute the values of m, e, epsilon naught, h, this you must have done definitely. You would and express it in electron volt, you would have got this as 13.6 divided by n square. So this is the expression for energy of electron in any orbit, that is the nth orbit. Now if you substitute the values for the first orbit, n is 1, second orbit it is 2, and the third orbit they have asked it is 3. So you would get E3 is equal to minus 13.6 divided by 3 square is 9. Just pause for a while here and look at the options. See, three options, 3.4, 4.53 and 4. If you divide 13 by 9, you don't get, only the first option is the correct. So the correct option here is A. So this is how you can arrive at the correct answer without going into the calculation. But you need to remember these expressions. So my advice for you students is, when you are discussing or preparing for questions like this, make it a point to write the formula, that's the required formula, you need it, and from that formula you arrive at the answer. You don't require much time for that. The next question is, if an electron in a hydrogen atom jumps from an orbit of level n equal to 3 to the orbit of level n equal to 2, the emitted radiation has a frequency. It should be in terms of Rydberg constant and the speed of light c. And so the options, as you see here, first one is Rc by 25, second 5 by 36 Rc, 3 by 27 Rc, 8 by 9 Rc. Now in case of such questions, you cannot come to the right answer unless you know very well one option. Otherwise is, you can work out very fast, you can work out expression here. See, the energy that is liberated due to the transition from n equal to 3 to n equal to 2 can be written as delta E equal to E3 minus E2. And then here for delta E, you write h nu, that is energy liberated, and for E3 and all that, z is 1, so mz square E4 divided by 8 epsilon naught square and h square and into bracket. You have the corresponding quantum number. See this minus E2 first that comes. So I will write 1 by n2 square minus 1 by n3 square. All right. And now I take the values, n2 is 2 and n3 is 3 in this case. So when I substitute that, before what I do is, I will take this h to the right hand side so that it becomes h cube, and one term I need extra here. So I will write here c h cube, and the numerator I bring a compensate for that. So now what all you have? Frequency of the radiation emitted becomes m to the power of m into e raised to power of c, the E4 c divided by 8 epsilon naught square c h cube. And once you write this term, immediately you should recall that this is nothing but Rydberg constant. So, if we can get that as Rydberg constant, you find it very easy. So, frequency nu equal to R into C, and here it is 1 by 2 square is 4, 1 by 3 square is 9, and LCM will be 36. So, your denominator 36, 9 minus 4 is 5. So, 5 by 36 into RC, which is the correct option then. So, the correct option is B, 5 by 36 into R into C. So, now here what is the additional? Along with knowing the expression for energy, you should also know that what is the expression for Rydberg constant. So, here you can highlight Rydberg constant is m E4 divided by 8 epsilon naught square C H cube, and to bring that Rydberg constant you make these the additional value, take C here, so that C you get in the denominator, and this entire term will be replaced by Rydberg constant. So, you are being familiar with all these expressions. The next question is, what is the wavelength of light for the least energetic photon emitted in the Lyman series of the hydrogen spectrum? You should take Hc equal to 1240 electron volt. And look at the options here. First is 102 nanometer, 150 nanometer, 82 nanometer, 122 nanometer. Look, in case of this kind of problems, you cannot arrive at the answers just by looking or recalling anything, unless you at least work out something. But while you are working out, please look at the words that are given in the problem. Wavelength of light for the least energetic photon of Lyman series. So, Lyman series means you have to fix the N1 and N2 values. That is, N1 is 1 and N2. What do you take N2? N2 should be taken for least energetic photon, N2 has to be 2. So, like that you have to first fix the values of principal quantum number, and then they have asked you to find out the wavelength of the light. So, again let me write this. See, E, that is energy emitted, I would write delta E is equal to E2 minus E1. So, you have to recall the energy of the electron in the second orbit and first orbit of hydrogen atom. From the previous discussion, we have seen minus 13.6 by n square. So, let me write directly this value as how much? E2 is, I must write this is minus 3.4 and minus it is 13.6. So, what this value turns out to be? Many times you would have done it, it is 10.2 electron volt. Now, look here, you are asked to calculate wavelength of light for the least energetic photon. So, now for this delta E, again let me write h nu, and h is you have to take in C by lambda. So, h into C by lambda you get is equal to 10.2 electron volt. And once you reach this point, you again look at the quantity that is given in the problem. You are asked to take Hc equal to 1240 electron volt, and that is why I will rewrite this lambda is equal to Hc divided by 10.2, both are in electron volts only, and Hc you substitute here 1240 divided by 10.2. Now, one more point I would like to emphasize here. The moment you get this, you start calculating, you think of working out, but please make use of some simple approximations. Suppose I ignore this 2, then what it would become? 1240 by 10, then the answer would have been 124. And because of this 0.2, there may be slight reduction in the value. So, now you go to the options. The nearest option is the D1, that is 122 nanometer. So, the correct answer is D. You have to write 122 nanometer. The next question, the relation between half-life and decay constant is what they have asked, but it should be expressed in the options. Look at that, lambda t equal to 1, lambda t equal to half, lambda t equal to log of 2 to the base e, lambda equal to log of 2t. As you see, the relation between half-life and a decay constant they have asked, and the 4 different options they are given. See here, in case of such, do not hurry up to mark the answers options. Please recall the equation that you know in for half-life in terms of decay constant. So, T is equal to 0.693 divided by lambda. All of you would have written many times this. Then you need to know 0.693, how did you get it? It is nothing but log of 2 to the base e. So, I would recall and write this log of 2 to the base e divided by lambda is this t. And once you write this, you will definitely come to the answer. So, lambda into t is log of 2 to the base e. So, the correct option is C, which you find it. So, I would say that again it is a very simple question, provided we know the knowledge or we have the information with us that is required to solve the problem. Next question is, a radioactive decay can form an isotope of the original nucleus with the emission of particles. See, in case of such question, see, let us have a look at the options. First option is 1 alpha and 2 beta, 4 alpha and 1 beta, 1 alpha and 4 beta, and 1 alpha and 1 beta. So, when you go through these options, definitely you get confused. That is how the questions will be framed sometimes. But if you just catch the points here, see, radioactive decay can form an isotope of the original nucleus. So, first you should catch hold of the term, what is an isotope? Isotope is an element having the same atomic number but different mass number. Let me write this X, Z is atomic number and A is the mass number. So, that is how we write. So, isotope is the one which has same atomic number but different mass number. This one information should be with you. Then they have asked what the emission of particles, alpha, beta, like that. But do we know what happens when a nucleus emits an alpha particle? When the nucleus emits an alpha particle, its atomic number decreases by 2 units and mass number decreases by 4 units. Please note, atomic number is reducing by 2 units and mass number is decreasing by 4 units. And when a beta particle is emitted, the atomic number increases by 1 unit and mass number remains the same. So, because of the emission of alpha particle, if the atomic number has reduced by 2, to compensate for that, you need to have 2 beta particles, and hence the options, if you go through the first, 1 alpha particle, 2 beta particle is the correct option. So, that is the answer for the question. And now you will definitely say that this is also a very simple question, provided we know all the 3 points. One, I said what are an isotopes, what is an isotope you should know. What happens when the nucleus emits an alpha particle, you should know in terms of atomic number and mass number, and what happens when a nucleus emits a beta particle. If you have this information, definitely you find again this is a very, very simple question. So, you agree with me that a question can be simple provided we have the necessary information with us. Students, we have another very tricky question here. The half-life of a radioactive substance is 20 minutes. The time taken between 50% decay and 87.5% decay of the substance will be. See, I think you cannot answer this question offhand unless you give serious thought. Thought process you must do. See, otherwise you will be gambling 40 or 10, 30 like that. But if you analyze the question, see, half-life of a radioactive substance is 20 minutes. Then shall we ask, do we know what is half-life? This is what you should do. Half-life of a radioactive element is the time during which the number of atoms of a radioactive element reduces to half of its initial number. You should know this. Knowing, not to write the definition, but knowing to make use of that information in solving the problem. So, let us say that we know what is half-life, that is 20 minutes. Now, time taken between 50% decay and 87.5% decay. How do you analyze? See, let us take this as t equal to 0. Let me write here. So, starting from this initial, let us say n0 or whatever it is, to reduce it to 50%. So, what time it takes? It will be t equal to 1t, that is half life, which you can write it as 20 minutes. So, now it has become 50% here. Now, from this point, again you have to, it should become what? See, it will reduce to 25%. So, 25% it will reach this point after another t equal to t. So, yet another t means total time t will be 2 times t. So, I must write it as 40. So, after 40 minutes it is 25%. But look here, 50 plus 25 means how much it becomes? 50 half of 25 you have to add to this. So, this will be 75%. What is that they are asked? Next, 87.5. Now, to this from 25 you should go to another, see, half-life t equal to 1t means 40 plus 20, that is 60 minutes. What it becomes? It becomes 12.5. So, now you look here, 50 plus 25 is 75%, and then it is another 12.5. So, how much it would be? It is 87.5%. Look, what they have asked is time taken between 50% decay and 87.5% decay. So, here time taken for 50% decay is this. Another, see, 25%. So, means what is the decay here? 50 plus 25, 75% decay. Then from this another 12.5. So, total decay is 87.5%. So, now the time here is 60 minutes. But what is being asked? Please note, time taken between that 50% decay and 87.5% decay means you should focus between these 2 points. So, when you are asked to find out the time between, this is 60 minus 20, and what will be the time? The correct answer is the 40 minutes. So, the first choice is the correct one. Another question, very simple question. A force between two protons is same as the force between proton and a neutron. The nature of force is, the options are weak nuclear force, strong nuclear force, electrical force, gravitational force. And most of you know the answer, the correct answer. But here I would suggest, at least just recall something when you read this question. The basic forces in the nature are, which are those forces? 4 types you should recall. So, you know that they are gravitational forces, then electromagnetic or electrical forces, then weak forces we call, and the fourth one, strongest, the nuclear forces. This you have studied. You just recall. Then, after having said this, about nuclear forces, what all you have learned? See, you have said, you have learned that nuclear forces are short range forces. They are charge independent forces. Then you said they are spin dependent forces, so on, so forth. Now, you just take charge independent forces. And once you say that they are charge independent, then you can be convinced that the same force exists between proton proton, proton neutron and neutron neutron, which together are given the name as nucleons. And once we know so much all this information, there is no need to wait for any more time. Immediately you can say that the correct choice here is the strong nuclear force. So, another question we have, students, here. An alpha particle of energy 5 million electron volt is scattered through 180 degrees by gold nucleus. The distance of closest approach is of the order of, options are here, different 10 to the power of minus 12, minus 16, minus 10 and minus 14. Now, here unless we have worked out before, you cannot come to a correct answer, but let us spend little time in understanding this problem. See, what is the closest distance of approach here they have asked. See, you should think that there is a nucleus here, as they have said, gold nucleus, and the atomic number of gold, see, Z is 79. So, Z into E, that is the charge of the gold nucleus, whose charge I have written Ze, which is positive. And you think that an alpha particle whose charge is 2e is approaching the nucleus. Now, here you should visualize, as this alpha particle with energy is moving towards the nucleus, which is also positively charged, it experiences a repulsive force. And due to this repulsive force, what would happen to its energy? Its energy goes on decreasing because work is done against this repulsive force. So, almost when it reaches a certain distance here from away from the nucleus, all its energy, kinetic energy, would have been reduced to 0 and it gets converted into the potential energy. So, this minimum distance of approach of the alpha particle to the nucleus is what we call as the impact parameter. So, in the problem they are asking us to calculate or estimate what could be this distance. And the trick here, see, the kinetic energy you know, which is 5 million electron volt, and that should be equal to what? The potential energy of the system, that is alpha particle and gold nucleus. So, we should know the expression for kinetic energy, we should know the expression for potential energy. You have written many times rather. So, I will write like this: kinetic energy half mv square is equal to what? The potential energy 1 by 4 pi epsilon naught into Z E square, Z E into, I should write 2E divided by R, and where R naught I will take, this is the distance of closest approach. So, the kinetic energy of the alpha particle is equal to the potential energy of the system, where R naught is the impact parameter. So, R naught equal to, then look, I will bring this kinetic energy term to the denominator, and this substitution 9 into 10 to the power of 9, Z is 79, I will write here, and 2 I retain as it is, E square, which is 1.6 into 10 to the power of minus 19 the whole square, and this divided by, you have kinetic energy 5 million electron volt, 1.6 into 10 to the power of minus 13. Definitely you would feel that it is quite cumbersome, but once you want to solve this problem, you need to go through all this. But with little approximation you can plan here. See, what you do here is you multiply this 9 and 2, you write it as 18, and 79 you take approximately 80. So, that is why I write approximately, and this 1.6 square and this 1.6 I will cancel out. So, 1.6 is remaining, 10 to the power of minus 38 you have, and this 13. So, 13 plus 9 is 22, and from 38 you subtract. So, minus 38 plus 22, how much it will be? 16. Now, after having said this, I will take this as denominator 5. So, one more approximation I will do. nearly you want. So, this 0 I cancel out with this, and 5 3s are 15 I will make, instead of 16 I take 15 and cancel out, and this I take it as 20, and let us see what I would get. So, it is 2 8s are 16, 160 into 3 480. So, 480 into 10 to the power of minus 16, then how much you get this? See, 4.8 into 10 to the power of minus 14. I will write here nearly 4.8 into 10 to the power of minus 14 meter it is. What they have asked is in centimeter. All the options are in centimeter. So, if you convert this into centimeter, what will happen? Don't worry about this number. 10 to the power of minus 14 meter is nothing but 10 to the power of minus 12 centimeter. So, the correct option is here A, which is 10 to the power of minus 12. Students, we have another question. Please look at this. A nucleus at rest splits into two nuclear parts having radii in the ratio 1:2. Their velocities are in the ratio. So, you are asked to find out the ratio of their velocities. So, if you just go carefully through the problem, see, initially the nucleus is at rest. So, let me show that this is the nucleus, original one. Say whatever you can take it as mass. It splits into two nuclear parts. So, suddenly if it splits, then two parts you take them as the smaller ones, and I can call that their masses will be, say, less than this m1 and m2. Now, one important point, the diagram should make you to recollect, this is nothing but the law of conservation of linear momentum. See, this nucleus is at rest, and once, because of reaction, it splits into two. These two parts should move always in the opposite direction. So, if it is taken to be moving along this direction, this should be moving in the exactly opposite direction to make the law of conservation of linear momentum valid. So, let me write this as V1 and this as V2. But look, what they are asked is radii are in what ratio, but we have the masses here. So, we can think m1 can be written as what? 4 by 3 pi r1 cube, it is a volume, into, let us take it as density of the material. Then similarly, m2 can be taken as 4 by 3 pi r2 cube into rho. So, what is the additional information one need to know? We wanted mass. So, mass should be equal to volume into density. So, you take some value for the density and write this equation. Once you write this, you recall the law of conservation of linear momentum. M into U should be equal to m1 v1 plus m2 v2. So, making use of law of conservation of linear momentum, I have written here m into u equal to m1 v1 plus m2 v2. Now, initially the nucleus is at rest. So, I should equate this to 0. m1 is 4 by 3 pi r1 cube into rho, you get v1, and here m2 is 4 by 3 pi r2 cube into rho into v2. So, now after this, see, I can write here as 0 equal to 4 by 3 pi r1 cube into rho, and I should write this minus because they are moving in opposite direction, 4 by 3 pi r2 cube into rho, that is equal to 0. And I forgot to write this v1 and v2 you should add. So, once you write this and equate them, so you will get v1 by v2 is equal to what? v1 by v2 is equal to r2 by r1 raised to 3. v1 by v2 is equal to r2 by r1 raised to 3. So, you are asked to find the ratio of their velocities. So, it is v1 by v2 and you are given ratio of the radii 1 is to 2. So, 1 is here and 2 is here. So, 2 by 1 raised to 3. So, the correct answer will be 8 is to 1. So, the correct option here is 8 is to 1, that is C.